Welcome back to another video where we'll be solving the CoinFlip challenge. So to get new instance, just go to Ethernaut.OpenZeppelin, click on get new instance. So as we can see, we've created a level instance. Let's read the challenge. So this is a coin flipping game where you need to build your winning streak by guessing the outcome of a coin flip. To complete this level, you need to use your psychic abilities to guess the correct outcome 10 times in a row. So we'll not use our psychic abilities, but instead we're going to use our expert advanced blockchain development skills to exploit the crap out of this contract. Let's read through the contract itself. So it uses any version above 0.6, so that's important. So this contract is prone to some errors like overflow and underflow if it was not using SafeMet, but this contract it is. So it says it's going to use SafeMet for UIN 256. This is the main function that does the flip. So this is a game, so this should be random, but we'll see if it really is. So you just pass in your guess to this function, and if you guess correctly, this will return true, and this variable will increment, and we should get this to up until to 10 without fail. So it should be consecutive wins, as this suggests. So let's see how this flip function does the math. So first it takes the block number and it subtracts by 1, and from this number, and by the way, block number is just the height of the blockchain, I think it's called. This is the last block, the number of the last block on the blockchain. Block hash is a native function in Solidity that just hashes this number and returns bytes32 variable that we convert to this number. So we store this here. We just check if this is the last hash, so immediately revert. This is not really useful. Then we take this value, divide it by factor, and this factor is just a hard-coded number of type UIN 256, and we get some number. If this is 1, we say this is true, else this is false. So this is the outcome of the function, basically, the random output. And we just check if this is the same as your guess. If it is, we'll return true and increment this. If it's not, we'll just restart this variable to 0. So that's basically the logic of this flip function. So what is the problem with this function and how can we exploit this? So basically the Ethereum blockchain is a deterministic technology, which means you always get the same output if you have the same input. You can read more about this on Google, of course, but because the nature of the Ethereum blockchain it's very hard to get randomness on the blockchain itself, and you shouldn't be using global variable such as block.number to get the randomness, and we'll see why now. Basically, if anyone wants to, he can guess the outcome of this function, basically this side value, just by copying the code into its own contract, because block number is going to be the same variable in this contract and as well as the Tucker contract, and we can again use block hash, etc. We can again divide by this factor because this is not random. The only not really random number we have here is this block number, but again, this is derived from the blockchain, and in any contract at the specific point in time, this block number will be the same, as we'll see now. So I've developed this attacker contract, and I'm going to explain the contract and deploy this to the Remix blockchain. So if I were to deploy this contract, as I did now, click on this get current block number variable, which just returns the current block number. And since I've deployed this to the Remix local blockchain in this browser, it's going to return 1. So this blockchain, this virtual sandbox development blockchain in Remix, creates a block in each transaction whenever you make a new transaction. So if you deploy the contract again, this is making a transaction, and check the block number now, you'll see this is 2. And if you were to deploy this contract to the Ring-B testnet, you'll see a different output. You'll get something like, I don't know, 11 million, I think, It's around, the last block number is around 11 million on the ring B blockchain or testnet. And how did I hack? How can I guess each flip? Basically, I'm just copied the logic of the flip function uses, but since I'm using a 0.88 version, I don't need to use safe math, so I'm just saying minus. When I do subtraction, I just say -1, and I get the hash of this number. Then I divide by factor. I get this coin flip if this is equal to 1. Then we get basically this output. And what I've added is I've added an interface to the contract that we've deployed, and we need to hack or exploit. And I've added just the function signature to this contract. Basically, we'll be calling this flip function to make a guess and complete this challenge. So in the flip function, I'm creating an instance of this contract by passing in the address of this contract, and I'm just calling flip function with the output we got here. And how can you get the victim contract address? Well, after getting new instance, this Ethernaut deploys this contract to the ring B testnet, and it provides you the instance address, which is here, which you can also get by saying contract dot address. So you can see this is the contract address, and what we can do is we can simply read this from the blockchain. We can see this contract on the blockchain. So if I search this contract, go into this is a verified contract, so you can go ahead and read the data from the contract. We only have one variable, consecutive wins, which is currently 0. We should get this up to 10. So how can we make that? Well, I'll deploy this contract to the ring B test network. So here I'll go ahead and select injected provider, and your MetaMask should be on the ring B test network, and I'm going to deploy this CoinFlip contract. So confirm this deployment transaction. After the contract is complete, go ahead and copy the address of the CoinFlip victim contract, go into Remix and pass this address as an argument to this flip function and click on transact. So this function will basically generate the correct output for us and call the flip function on the victim contract with the correct outcome. And after this transaction is mined, I'll go ahead, go into the contract, CoinFlip contract itself, and see if we incremented the consecutive wins variable. So go to contract, read contract, and if I see consecutive wins is now 1. So we've successfully broken the code, so to speak, or at least we did that once. To do it, and now we need to do this 10 times. So just make 9 more transactions by calling this flip function, and I'll catch you back once I'm done. Or actually, I'm not going to bother making 10 transactions because I already know this works, because I've completed the level multiple times. So once you finish with your 10 transactions, now I have only 2. Just go back to your challenge and click on submit instance, and this should finish your level. So that's how you complete this challenge. So what are the key takeaways for this challenge that you need to learn? So full credit goes to D Squared challenge for providing these resources. He has also made a tutorial or a full playlist where he solves all the Ethernaut challenges. So I'll just share those. So you have entropy illusion. This is basically the illusion that you can actually get randomness on the Ethereum blockchain. That's one thing you need to learn and take away from this video. Second thing is never use global variables in Solidity to get randomness, because global variables like block.number or block.timestamp can be manipulated by miners, and they can basically exploit your contract in this way. The third thing to take away from this video is that the Ethereum blockchain is deterministic, and think of this as all the nodes on the Ethereum blockchain run the same code and all the nodes arrive at the same state. So how do you get randomness if the blockchain is deterministic? Well, you can use Chainlink VRF. This is a solution from Chainlink to get the randomness in a decentralized way. This is another way to get the randomness, and there are a bunch of others. I have only experience using Chainlink VRF. Also, make sure to check out this resource, the problem with random number generation in Ethereum. And also make sure to check out the D squared video. He also, I think, mentions even more resources.